Data for training. In this video, we will explore a fundamental step of deep learning, which is the data to train the neural networks. Data is the fuel that powers the learning process of artificial intelligence models. It serves as the foundation upon which these models are built and trained to recognize patterns, make predictions, and generate meaningful insights. The availability and quality of data directly impacts the performance and effectiveness of deep learning algorithms. When training a deep learning model, a large and diverse dataset is crucial to expose the model to a wide range of examples and variations, enabling it to learn robust and generalizable representations. The more data we provide, the better the model can learn and understand complex patterns and relationships in the data. Additionally, the quality of the data matters, as it influences the model's ability to generalize well to new, unseen examples. This tool will help you explore the training data aspect of deep learning. Let's explore it. Here we have a couple of dataset examples. We have the iris flower classification and the house price prediction. We also have the description of the selected example. So let me go through a few words about the iris flower example. It's considered to be a hello world of machine learning and a classification problem where we predict the flower class based on its petal length, petal width, sepal length, and sepal width. Now let's see what the second example is about. So I can select the price prediction for houses here. And it says Boston house prices dataset consists of prices of houses across different places in Boston. The dataset also consists of information on areas of non-retail business, INDUS, crime rate, CRIM, age of people who own a house, age, and several other attributes. The dataset has a total of 14 attributes. Let's switch back to the first example. Iris flower classification. Next, we have a link to the home page where this data is available for anyone to learn about and download it. Let's visit the home page. Many machine learning libraries have built-in functionality to load data from these types of data sources and repositories. Now let's go back to the tool. We can make the data viewing easier by downloading the data sample using this link. It will download as a CSV and we can view it in our favorite text or spreadsheet viewer. Next, this tool displays data as a sheet. As we can see, it has 5 columns, 4 for input and 1 for output. The column headings and their order are provided in the dataset homepage. And they are like this. The first column is sepal length. Second column is sepal width. Third column is petal length. And the fourth column is petal width. All of these measurements are in centimeters. The fifth and last column is the flower class, which includes iris setosa, iris veriscolor, and iris virginica. Next, we have the network architecture of a deep learning model, showing the input layer, the hidden layers, and the output layer. The input layer receives the data as 4 input values, consisting of sepal and petal dimensions. This data is then fed into a set of hidden layers, and each hidden layer has an appropriate number of neurons. And it also has to make an appropriate choice of an activation function. We will learn more about how to set up the hidden layers for different machine learning use cases in later sections. The output layer receives the signals from the hidden layers and computes the probability of each of its classes. These predicted probabilities are compared to the actual true values in the dataset, which are in the form of a number 0, 1, or 2, referring to one of the zero-based class numberings. Next, we analyze the input features tensor. The rank of this data is 2. In other words, each data element can be expressed using the row and column number. So for example, we can look at data row 3, column B. Hence, its shape is n rows and 4 columns. This rank 2 tensor can be displayed like this. Finally, we have the output labels tensor. The rank of this tensor is 2 because there are n rows and 1 column. Each data element in this tensor represents the output class with respect to its row number. So in this example, class 2 is the class for the first row, and class 0 is the class for the second row, and so on and so forth. This completes the walkthrough of this tool, showing different concepts used to train the iris flower data in machine learning. Similarly, we can explore the second example by scrolling to the top and selecting Predict House Price. And this is about predicting the house price in a particular city. As you can see, the tool updates all images, views, and contents accordingly. This covers how this tool can be used to explore the fundamental step of deep learning, which is the data to train the neural networks. Feel free to explore these examples with the tool and read more about how data is collected and modeled for these and other popular examples.